This is the second video in our sequence for discussing photosynthesis of glucose. So we're using this information, and we're going to try to deal with questions 6, 7, and 8 here. So question 6 says, what mass of carbon dioxide is used if 2,000 kilojoules of energy is converted to chemical potential energy in photosynthesis? Draw an energy diagram for the catalyzed photosynthesis reaction. How would the graph look different if the reaction was uncatalyzed? So those are our three questions. Now the first question gives us an amount of energy. So it's telling us that the energy that we've got in the reaction, or the Q, is 2,000 kilojoules, and it wants to know what the mass of carbon dioxide would be if that reacted. Now the molar mass of carbon dioxide is 44.01 gram per mole. And as soon as we're talking about mass, we know we're going to deal with molar mass. Well, in the previous video, we had discussed how the energy difference between the cellular respiration and combustion are different because the state of matter for carbon dioxide in those is different. So you get different formation enthalpies. Well, I've gone and calculated what the enthalpy of cellular respiration would be, and it's negative 2,802.5 kilojoules. So the enthalpy of this reaction is negative 2,802.5 kilojoules. Already, if 2,000 kilojoules are going to be given off, then it's got to be less than 6 mole of carbon dioxide, right? We can see it takes 2,000, or 2,800, this is 2,000. Now, the key here, though, is you've got an energy for 6 mole of carbon dioxide. So the enthalpy of combustion that we get for carbon dioxide is going to be negative 2,802.5 kilojoules, but that's for 6 mole of carbon dioxide. So if I take my 2,802.5 and divide it by 6, I get negative 467.08 kilojoule per mole of carbon dioxide. Well, if my Q value divided by my molar enthalpy was applied, that would be my N, right? Because N times molar enthalpy equals the energy transferred. So I've just rearranged this to find N. And so I've got 2,000 kilojoules divided by 4,607.08 kilojoule per mole. And this is going to give me my mole of carbon dioxide. So if I take 2,000 divided by 467.08, I'm going to come out with 0.4. Oh, I screwed that up. Sorry, 2,000 divided by 467.08. I get 4.28 mole of CO2. And so I'm going to take the number of moles times the molar enthalpy equals the mass, and that'll give me the mass of carbon dioxide. So if I take this by times 44.01, I'm going to get 188 grams of carbon dioxide are being produced in that reaction. Now, the next question said, draw an energy diagram for the catalyzed photosynthesis reaction. This was my photosynthesis reaction, but if we had activation energy, the activation energy barrier is going to be higher than the enthalpy, right? So the difference from here to here is the activation energy. And the enthalpy is the difference from here to here. Well, if it was a catalyzed reaction, though, and it must be a catalyzed reaction, the activation energy will be lower. So now the activation energy for the catalyzed reaction is from here to here. This is an oversimplified graph. I don't know that you actually could carry out photosynthesis without a catalyst. So its energy diagram might be up here, and then the catalyzed energy diagram would look like this. But the idea that you need to know is the catalyzed activation energy is lower. It reduces the amount of energy required to make the reaction occur, but the enthalpy change is unaffected by the catalyst, right? It's the same net amount of enthalpy. If it was an uncatalyzed graph, to answer the question 8, the activation energy would be higher, right? And so it might actually be so high that it's impossible to essentially occur. But the key concept is the catalyzed is a lower activation energy than the uncatalyzed. Net enthalpy is the same.